Conductive Play-Doh lab.
So I started with a bowl because I thought it would be easier to mix everything up in the bowl and then add it to a saucepan later. So here I am getting the 1 cup of flour, and then I added my water, and I'm adding some salt, which is the component that'll make it conductive. So that's very, very important. And then I'm adding lemon juice, which is another acidic component that will add, again, a conductive property to the mixture. So here I'm adding the 9 tablespoons. And then here I am adding the vegetable oil, which just makes it more like doughy and have everything stick together. So I added that, and now I'm adding it to my saucepan, and I did this not at the stove, so that's me getting a rubber spatula so that I can add it to the saucepan without losing any of it. So I added it there, and then I mixed it up a little bit just so that it was ready to go. And then I brought it over to the saucepan, turned it on to medium heat, and I got a wooden spoon so that I can mix it over heat. There I am, just stirring it all together until it forms a ball. And it took a while to stir, but eventually it did form the ball that was needed. So here's me just stirring some more. It was starting to get thicker, and then there it is as a ball. I brought it over to the counter, which I put a ton of flour on so that it wouldn't stick. And then I thought it was more effective to not only have the flour on the countertop, but I would add like a little bit of flour, about a tablespoon at a time, to the like straight onto the dough, which I thought really helped. So there's me kneading, and it took a while to knead. I think I kneaded for about like 5 minutes, and it finally turned into the texture that I wanted. After kneading and adding flour, the final product looked like that. So I started by adding the base, which was 1 cup of flour. So there's me measuring the flour into the bowl, and then after that, put it away, and I got the sugar, which is what makes it non-conductive, because unlike salt, sugar is an insulator and resists the flow of electricity. So I added that, and then I added the vegetable oil, which is just an essential component that makes the mixture like soft and everything stick together. So I added the oil, and then stirred it up, and I actually had a lot of trouble with this lab. You'll see when I start kneading, just because it was a lot more sticky, because I think just because sugar and water is a more sticky mixture than salt and water is. So here I am just mixing everything up, and then I got this Essentia water, which was purified. So I measured out half a cup of that, and then I added it to the bowl and mixed it up, and I added it very slowly. I added like just a tiny bit at a time. So I mixed it, added some more, mixed it until it dissolved, and then I repeated this process until all of the water was added and dissolved. So at about this point, I started getting pretty frustrated just because this mixture was a lot more liquidy and sticky than the conductive Play-Doh was. So I had to mix it a lot, and I ended up having to add a lot of flour. And there's me continuing to stir. I ended up picking up with my hands, and I had to get my sister to help me add flour, and I was getting very frustrated. But I ended up adding enough flour, and it worked out fine in the end. Series Circuit Lab. To prepare for all the circuit labs, I put batteries in the battery packs and arranged the wires in a way that the electricity flowed, and then I put tape on all the LED lights that I exposed the wires to show again which way the electricity flowed. Started by joining the wires and forming a series circuit with just one light, and it clearly lit up very bright. And then I added the second light and both of them lit up. However, they were both kind of flashing back and forth, like one would turn on and the other wouldn't, but they would keep each turning on, so it did work. And then when I added the third light, that's when I had more trouble. I would get one to turn on and then the rest wouldn't, so I kept configuring it in different ways and rearranging the lights in different orders, and eventually one would light up, and so yeah, you can clearly see that it's lighting up, but it wouldn't work to the fullest extent.
On either side, but we know which one is the right direction, and all the LEDs work when alone, but when connected, none of them turn on. So we know that it's not the light, we think that the batteries aren't quite powerful enough.
So here's me making the series circuit and repeating the steps with the non-conductive Play-Doh, and I assumed that they wouldn't work, and they didn't. The only time it would work was when the Play-Doh obviously wasn't involved and the wires were just touching each other, and not having to travel through the Play-Doh. And because of its insulating properties, the electricity can't travel through the Play-Doh, which is why none of the circuits work no matter how many lights there were. So yeah, here's the video of them clearly not turning on no matter which way they were. Parallel circuit lab. So again, I started by arranging the wires and battery packs using the conductive Play-Doh in order to form a single light series circuit, which is very simple. So I set that up. Here I am doing that, and there I am putting the Play-Doh down. Then I added the LED light with the wires arranging in the correct spot. And once I did this and put it in the Play-Doh, it lit up very bright after I turned on the batteries. There it is, shining pretty bright. So then after I did that, I turned off all of the battery packs, and I began to add the second LED light to the parallel circuit. And I found this lab to be a lot more simple than the series circuit, and I think that's just because of the fact that the energy travels only in one direction in a series circuit, and I think that our batteries and LED lights weren't quite powerful enough to charge all three of the lights separately in the same direction. So here's the parallel circuit with two lights. They both lit up pretty bright. They're kind of flashing a little bit, but still very bright nonetheless. I turned off all the battery packets again, and I added the third light to the to the parallel circuit. There I am, and I made sure that the wires were not touching, but they were all in the conductive Play-Doh. So that's me rearranging it to make sure that it was the right way. Turned off all the battery packets again, and again rearranging the Play-Doh so that they could all fit without actually touching the wires. That way we know that the conductive Play-Doh was being a conductor rather than a resistor. So here we are adding that. I had some trouble with getting all three of them on there, but once I got it, they all did light up, as you can see, you'll see in a second. So here I am just making sure that they are all in the conductive Play-Doh. And there they were. And they were all lighting up. So I knew that it wasn't the problem that they were all connected to it. So then I put them back in the Play-Doh and they were all lit up. So after I set up the parallel circuit and got it working with the lights, I turned off the battery pack and I took apart the Play-Doh and I put it back and I began to try using the non-conductive Play-Doh. And again, I realized that it wasn't going to work unless the wires were touching, which defeats the purpose of the lab in testing out the conductivity properties of the Play-Doh. So I set it up and tried it with one light and didn't work. So then I turned it off, added my second light, and again it didn't work. So again I tried with the third and the clay would not allow the lights to light up. Series and parallel circuit lab. So to start, the same as all the other labs, I arranged it into all the wires and all the battery packs into the same series circuit with the conductive clay, and I added one LED light and turned all the battery packs, and after some playing around with it, it lit up. So you can see in a sec that it'll light up. So there we go, it lit up. So then I added one more piece of Play-Doh and I put one light attached to one of the two pieces of clay, and then I put two LED lights on the other two in order to connect it. So we had a series and parallel circuit at the same time, which is really interesting. And I was a little bit worried about this lab just because I had difficulties getting all of them to light up when it came to the original series circuit when there were 3 lights. So I was a little bit worried about this one, but I think the batteries that I have just worked better in a parallel circuit. So it did end up working, as you'll be able to see in a second. So once I got it all arranged and I got all the lights turned on, which took some finicking, but obviously it was able to work with the conductive Play-Doh, I turned off all the battery packs, and I turned it off, and then I took apart all the Play-Doh and got my non-conductive clay, which obviously again is not conductive, so I figured that it wouldn't work. But one thing that I did realize that was interesting was even in the non-conductive Play-Doh, if the wires were touching, it would still light up. So it doesn't completely block the charge, but it does limit it, so it doesn't flow through the Play-Doh, which I thought was really interesting to see. So yeah, obviously did not turn on, and there you go, that's a series and parallel circuit.